In this video, we want to learn about sum to products formulas. Here you can see a list of these formulas. Sine of alpha plus sine of beta is 2 sine of alpha plus beta over 2 cosine of alpha minus beta over 2. Let's use this formula. To learn a formula, the best thing that you can do for yourself is always do a question. Only memorizing or by repeating the formula, you learn nothing. You have to use a formula, then by using the formula, you can get familiar how to use the formula and you learn the formula better. For learning this formula, we want to do this question. Sine of 3x plus sine of x. We want to write this in the product form. Sine of 3x plus sine of x based on this formula is 2 sine of sum of the angles alpha and beta over 2. So we have to add 3x to x. 3x plus x is 4x divided by 2. So 2 sine of 4x over 2 cosine of the difference of the angles alpha minus beta over 2. 3x minus x would be 2x all over 2. We can simplify this expression. 4x over 2 is 2x, 2x over 2 is x. So we can write this in the form of 2 sine of 2x cosine of x. So with the aim of sum to product formulas, we can write these sums or these differences in the form of a product, as you can see. And we can use these formulas depending to the question for simplifying expressions, proving identities, and other things. But here in this video, our focus mostly is in learning these formulas and getting familiar with these formulas. Also, I will show you how we can use them for finding the values of some expressions. Look at the next example. Cosine of 4x minus cosine of 2x. For this one, of course, we have to use this formula here. Cosine of alpha minus cosine of beta is negative 2 sine of, so this equals negative 2 sine of sum of the angles alpha plus beta. What is sum of 4x and 2x? 6x divided by 2 would be 3x. Sine of the difference of the angles 4x minus 2x. Attention, you have to subtract alpha from beta. Beta basically from alpha. So you have to subtract 2x from 4x. 4x minus 2x is 2x. 2x divided by 2 would be x. So this is the final answer for this question. So with the aim of the last formula, we write cosine of 4x minus cosine of 2x in the form of negative 2 sine of 3x sine of x. Before I show you the next example, let me mention something here which is very important. For doing these questions, sine of 3x plus sine of x, we use this formula. And based on this formula, this equals 2 sine of alpha plus beta. 3x plus x is 4x divided by 2. Then cosine of alpha minus beta. Here we suppose this as alpha and this as beta. What if this question was in the form of sine of x plus sine of 3x? This is same expression, but the order of the terms is changed. But the answer should be the same because it's the same expression. But if we had this, if the question was in this form, sine of x plus sine of 3x, then this would be your alpha and this would be your beta. Then this part would change for you because alpha minus beta would be x minus 3x. And x minus 3x is negative 2x. And then when you divide this by 2, then you have negative x, which is different than x here. But does this change the answer? Let me explain this here for you. If the question was in the form of sine of x plus sine of 3x, then the answer is the same, but the only difference is that instead of 2 sine of 3x cosine of x, we have cosine of negative x, because alpha minus beta is x minus 3x, divided by 2 would be negative x. But remember, we have an identity, we have a relation for cosine. Cosine is an even function. So please attention, cosine is even function. But what this means, when a function is even, it means that the negative is not important for the function. Cosine of negative x is the same as cosine of x. So there is no difference between cosine of negative x and cosine of x because these are equal. And this is because of the cosine is even function. When a function is even, the negative for the angle is not important. Cosine of negative 30 degrees is the same as cosine of 30 degrees. For this reason, it's not really important that if we consider this as alpha, this as beta, or if we consider this as alpha and the other one as beta, the answer would be the same. Doesn't change the formula. So I thought that this can be sometimes confusing for the students. So I thought that it can be good to explain this here. So remember, cosine is even function, but sine is not even. Sine of negative x is negative sine of x. For example, sine of negative 30 degrees is negative sine of 30 degrees because sine is odd function, but cosine is even function. Now let's continue to the next examples. We want to find the value of sine of 75 degrees plus sine of 15 degrees. So you can put this in a calculator and you can find by calculator these values and you can add them up. But here we want to find these values without any calculator. Here, as you can see, we have two trigonometric functions which are sine and we want to add them. Normally we don't know the value of sine of 75 degrees and sine of 15 degrees. But if we use the sum to product formulas, which in this case would be this formula, sine of alpha plus sine of beta is 2 sine of sum of the angles over 2 cosine of the difference angles over 2. If we use this formula, maybe it helps us to simplify this. Let's see how it works. This equals 2 sine of sum of the angles. 75 plus 15 is 90. Divide by 2 would be 45. So 2 sine of 45 cosine of the difference. 75 minus 15 is 60. Divide by 2 would be 30. So this equals 2 sine of 45 cosine of 30. If you remember from special triangles, when we have a 45 degree here, 45 degrees here, 1 root 2, the sine of 45 is 1, sine of 45 is opposite over hypotenuse, and it's 1 over root 2. So this equals 2 times 1 over radical 2. Instead of 1 over radical 2, if you rationalize this, this is like radical 2 over 2. But let's leave it as 1 over root 2. What about cosine of 30 degrees? For 30 degrees, if you remember a special triangle, when here is 30 degree, opposite is 1, adjacent is radical 3, and the hypotenuse is 2. Cosine is adjacent over hypotenuse. So it is radical 3 over 2. So times by radical 3 over 2. Now if we simplify this, we have the answer. These two from numerator with these two from denominator cancels, and we have radical 3 over radical 2. And this can be your final answer, but if you like, you can rationalize this by multiplying the numerator and denominator by a radical 2. Radical 2 times radical 2 is 2. Radical 2 times radical 3 in numerator is radical 6. So sine of 75 plus sine of 15 degrees is radical 6 over 2. Look at the next example. Cosine of pi over 12 plus cosine of 5 pi over 12. Again, normally we don't know the value of this, but we want to find their sum. Again, we can use the product to sum formula to find this. Let me remind you the formula for cosine of alpha plus cosine of beta. Cosine of alpha plus cosine of beta is 2 cosine of sum of the angles over 2, cosine of the difference of the angles over 2, cosine of alpha plus beta over 2, cosine of alpha minus beta over 2. So based on this formula, we have 2 cosine. Sum of these two angles, pi over 12 plus 5 pi over 12 is 6 pi over 12. Which is basically pi over 2. But don't forget, we have to divide this. This is alpha, this is beta. Alpha plus beta over 2. So we have to divide this by 2, which would be pi over 4. Pi over 2 divided by 2 would be pi over 4. So we have this equals to 2 cosine of pi over 4 times by cosine of the difference, pi over 12 minus 5 pi over 12 would be 1 pi over 12 minus 5 pi over 12 would be negative 4 pi over 12, which is negative pi over 3. But attention, this is your alpha, this is your beta, but you have to find alpha minus beta over 2. So you have to divide this by 2. Minus pi over 3 divided by 2 would be minus pi over 6. So we have cosine of minus pi over 6. If you remember, I explained to you that cosine is even. So cosine of negative pi over 6 is the same as cosine of pi over 6. So this equals 2 cosine of pi over 4 cosine of pi over 6. Cosine of pi over 4 is 1 over radical 2 or radical 2 over 2 based on the special triangle, because this is 45 degrees. Pi over 6 is 30 degrees and cosine of 30 degrees is radical 3 over 2. If we simplify this, 1 2 from numerator with 1 2 from denominator cancels, and this equals radical 6 over 2. So the value of this expression is also radical 6 over 2. Use sum to product formula to show that cosine of 100 minus cosine of 200 is sine of 15 degrees. So we have cosine of alpha minus cosine of beta. So we need to use the difference formula, basically difference to product formula, not really the sum, because it is a minus, but we say a sum to product formula, these type of formulas. So here we use this formula. Difference of 2 cosine is equal to negative 2, don't forget this negative 2 sine of sum of the angles over 2 sine of difference of the angles over 2. So negative 2 sine of sum of the angles divided by 2 sine of the difference of the angles, and here you have to subtract beta from alpha, alpha minus beta over 2, and don't forget the negative in front. So this equals, based on the formula, this equals this expression cosine of 100 minus cosine of 200 is equal to negative 2 sine of sum of the angles. 100 plus 200 is 300. Divide by 2 would be 150 degrees. So this equals 150 degrees. Then sine of difference of the angles. 100 minus 200, 100 minus 200 divide by 2 would be negative 100 over 2, which is negative 50 degrees. So sine of negative 50 degrees. Now we have to simplify this expression. If you remember, I mentioned that cosine is even function, but sine is odd function. And when a function is odd, it means that sine of negative 50 degrees is negative sine of 50 degrees. So you can bring this negative to the front, and this negative, when it goes out, you can simplify it with this negative and they cancel each other. Remember, sine is odd. If it was cosine, you can ignore the negative. But when it is sine, which is odd function, you can bring it here, and negative times negative would be positive. So the first thing that we do here is that we write this in the form of 2 sine of 150 degrees sine of 50 degrees. This sine of 50 is exactly this. Now our job is to show that this is 1, because we want to prove that this equals only sine of 50. We have the sine of 50 here, but we have this extra term here, so we have to show that this is 1. But why 2 sine of 150 degrees is 1? 150 degrees is an angle in quadrant 2. This is 150 degrees. And when the angle is 150, the reference angle for 150 is 30 degrees. If you remember from a special triangle, sine of 30 degrees is 1/2. In second quadrant, sine is positive. Sine is positive in quadrant 1 and quadrant 2. So sine of 50 degrees is the same as sine of 30 degrees because the reference angle is 30. And it is positive because in second quadrant, sine is positive. So sine of 150 is exactly the same as sine of 30 degrees. And sine of 30 degrees is 1/2. So this completes our proof. So we have this equals to 2 times 1/2 times sine of 50 degrees. 2 times 1/2 is 1, so this equals sine of 50 degrees. So we prove that cosine of 100 minus cosine of 200 is sine of 50 degrees. I hope by watching this video now you are familiar with some two-product formulas and you know how to use these type of formulas to find the values or how to write a sum in the product form. If you want to learn more about this, I have another video that in that video I will show you more advanced questions about this topic. If you like this video, please subscribe in my channel and see you in the next videos.